Hello there, everyone. This video is to help you go through the first part of CrystalMaker Assignment 4. And in this part, we will be looking at Miller Indices. So I know this is something that you all have talked about in class, talked about it in recitation recently, and hopefully by playing with it within CrystalMaker, it helps crystallize the ideas of the Miller Indices even more. Okay, jumping into things, your structure that you'll be looking at is in the structures library, you go to minerals, native elements, and then open the diamond structure. Ooh, diamond's fun. I will be using halite or table salt to demonstrate this instead of diamond, but the principles will all be the same. So I have halite open. You can see it here. This is just table salt for anybody who's not familiar, NaCl. But okay, what is our first instruction? First, we're going to go to the model inspector, and then this cube menu, we're going to tick the multiple unit cells box, and then ensure that the axial vectors are on and their labels are set to A, B, and C. Okay, so in CrystalMaker, we go to the model inspector. You can get there either with a keyboard command, or you can go to the menu model inspector, or just click this blue eye up in the top right. So then we want to go to this cube menu, the third from the left, and make sure your unit cell is ticked on. Make sure the multiple unit cells box is ticked on, and then also make sure the axial vectors are ticked on. And I've actually covered them with my camera. There you go. You can see them below me, right down there. And then we want to change them instead of X, Y, and Z to be A, B, and C. Okay. So now we just did a bunch of stuff. We should be good. You can't see my unit cell lines because they are within the bonds of halite. So the outer square is one unit cell. You might be able to see it if I like really increase the size, maybe turn it a different color. No, it's not cooperating with me. There are ways to get it to show up on. Oh yes, I had to change this. Okay, so now you can see. You might have seen. Let's make sure it saves. So the area is outlined in red. That is one unit cell of halite. But yours will be much easier to see on diamond. So I'm going to put my settings back to how they were. Okay. So we've done that. Back to the assignment page. Next step is to go to transform and then set range, and then tick live update and auto scale, and then click add cells until you have 9 unit cells. Okay, so we'll go to transform and then set range, or you can use the keyboard command. And then we'll tick live update and auto scale, apply. And we're going to add cells. So this is not 9 unit cells of halite. This is 1, this is 2, so this is like kind of 2 and change. So we'll add cells again. Good. Now we can see 1, 2, 3, 4, 5, 6, 7, 8, 9 unit cells. Apply. Perfect. Okay. Now I have 9 unit cells of halite. Looks good. Our next step is to draw a lattice plane. This is something that we've not done before, but it's not too crazy. So we're going to go to transform and then set plane properties, which is this menu option here. There is also a keyboard command that I would suggest you get used to using because we're going to be opening this menu quite often in this assignment. So we can click that. So we have the menu open, and we're going to draw a lattice plane by typing in 001 to the H, K, and L fields, respectively. So you can see them labeled H, K, and L. Go 0, 0, 1. And then you can click OK. But just first, before I do, there are some quick options here. So 1, 0, 0, and then, it's several options that you can just do quickly instead of having to type it in every time. Again, you can change the color of this, you can change the opacity, but I'm going to leave those settings as they are. Then I click OK. Doesn't look like it did very much until I turn the crystal, and you can see now there's this red plane running through my crystal structure. So now it's a little laggy, but you can see that by drawing that plane in there, or by using that setting, I have drawn this red plane through my crystal. Let's back out again. Okay, so now that we've drawn a lattice plane, what's next? Well, we're going to want to move the lattice plane using the plane tool to the surface of my crystal face. Okay, so in the toolbar over here, and if this is gone for you, remember you can turn this on and off with the top left button. Turns the tools palette on and off. And the fourth option down on the right-hand column is this plane tool. So you just click and drag, and now I can move this plane throughout my crystal. And so we want to put it on the face. So we'll just put it up here on top for now. Okay. So now we've moved it to the surface or the face of the crystal. And then we're going to add some annotations. This is another new tool for us. So the first thing we're going to do is draw 2 lines using the annotation tool. So we'll go to annotation, which is up here. By the way, if you can't see this option, if your toolbar looks different from mine up top, you go to Window, Toolbar, and then Standard Tool Set. If you have another one ticked, the options are different, but that was just Window, Toolbar, Standard Tool Set. And so we're going to add 2 lines. So I've added 1. It's difficult to see mixed in the back there. But there it is. And to move these annotations, you need this pointer option instead of the hand. The hand will rotate your crystal. The pointer will allow you to click and manipulate your annotations. And this is difficult to see on a black background. You can change the color, but I'm just going to change my background to gray. So now you can see the arrow a bit clearer. And so the instructions asked us to make 2. So we're going to make 2. We'll just keep those off to the side for now. And then we're going to, using the arrow to manipulate the lines and ensure there's one horizontal axis and one vertical axis that cross in the center of the crystal. And so let's look down an axis. Let's go View, A. Now I'm looking down the A axis. Remember to use your axial vectors down here in the bottom left to orient yourself. And so we are just going to cross these in the center of our crystal. So again, I'm still using that pointer tool. And you can click on the very tail end of it and click and drag, and it extends the arrow. Just there. Just moving my zoom tools. I know y'all probably can't see that in the recording. Click and drag. Crossing in the center, 2 arrows, perfect. Okay. So we've done that. And so what these are doing is they're helping us visualize where the crystallographic axes are. It would be really nice if we could like blow up these axial vectors here in the bottom left and like get them in the center of the structure. But as far as I know, we can't. So this is what we're going to use. We're going to have arrows going through here. And then to make it a bit clearer for us, we're going to play around with them a bit more. So with our arrow tool still selected, we're going to double click on the lines and change the properties so that they have double arrowheads and that they're easy to see. If you didn't change your background, maybe this blue isn't all that easy to see on black, so you could change it to something like red. And so now I have a red arrow, and you want to make sure that you click this double radio button. We'll do the same here. Make it red. Click double arrowhead. And we're good to go. Okay, now we want to label the positive and negative ends of the axes by adding text boxes. So even though CrystalMaker's axial vectors have the positive B running off to the left and the positive C running up and down, I find it's an easier convention for positive to be running right and up and negative to be running left and down. And these definitions are really just how we make them, so I'm going to choose to do that. So what we're going to do is we're going to make 4 text boxes, and still make sure you have these pointers, the pointer tool clicked. When you want to move those text boxes, they appear in the middle of the crystal structure. So we're going to make 4 of them. One more. Okay. And so whether I like it or not, the B is running horizontally and the C is running up and down, but I can define which is positive and which is negative. So to manipulate the text, you double click on the text box with the arrow tool. And for some reason, mine was wigging out there, but that's okay. We endured, figured it out. So you change the text in this box. So I'm going to make it positive B. And then I'm going to make it a bit easier to see. So let's make it 16 size font. Then hit apply. Okay. So now we have our positive B. We do the same for all the others. So this is my positive C. Change my font size. And I know on the Mac, this looks slightly different. So if your menu is slightly different, don't freak out too much. It should be pretty clear where these options are, even if it is slightly different. Don't like how my negative sign is floating above my C there. Much better. Lastly, negative B. Don't want to be changing those. Negative B. Change the font size. Okay. Apply. Excellent. Okay. So now we have axial vectors and labeled axial vectors with positive and negative ends. Awesome. Okay. And again, throughout this whole assignment, keep using these axial vectors to orient yourself. And like I said, you can choose the positive and negative ends, but you cannot choose, it's not up to our control what is horizontal and what is vertical if we're using CrystalMaker's defined viewing directions, which we are. Okay. So in the past, we've used copy graphics. This will not work for this assignment, unfortunately. If you do copy graphics, it will not grab the text boxes, so we got to do something slightly different. We're going to go to File, and then we're going to go to Export, Export Graphics. This pops up. Just, I would accept the defaults. It's okay. It'll make a nice picture. Then you just click Export. I believe the default, it saves to a BMP file. I wouldn't do that. I would do either a JPEG or a PNG, some sort of familiar image file, and then click Save. And so our next step is to replace this image. It says so in big text. So you can right click or maybe control click on a Mac, command click, I'm not sure, if you don't have a right click button. Anyway, you can always just delete the image and then copy in your own. But anyway, go to upload from computer, and then I'm just going to click that image I made, resize it. Okay, good. So now I grabbed everything that I wanted to. It has the labeled vectors. Awesome. So next part. While looking down the a-axis, do you see the surface of the lattice plane you inserted? Note you can only see the edge of the plane. If you can only see the edge of the plane, then it is parallel to the axis you are looking down. If you can see the surface of the plane, it is not parallel, and therefore that axis will intersect it. So let's go take a look. Where is our plane? We're going to click our plane tool. Okay, so my plane was sitting at the top of my crystal structure. So we can put it back there on the surface. So remember, the plane is here, up top. So the question is asking, while looking down the a-axis, do you see the surface of the plane? Well, no, we don't. We just saw it's a line. And so if you can only see the edge of the plane, it should look like a line, then it is parallel to the axis you're looking down. If you can see the surface, it is not parallel. Okay, so you would say, no, I do not see the surface. The lattice plane is parallel to the a-axis, crystallographic axis. Something along those lines. You don't have to copy me word for word. In fact, I'd prefer you don't. Okay. So now we're going to change our view so that we're looking down the B crystallographic axis. So we're going to go back to CrystalMaker. We're not changing our lattice plane, but we are changing our view direction. So now we're looking down B. You can see my axial vectors have changed. B is going into the screen. A is running side to side. C is up and down. And so we still see the edge of my plane, which is fine. We'll put that back. I don't know what it's doing there. Maybe if I zoom in, it'll... Funky. I don't know why it's doing that to my my bonds, but that's fine. It's kind of cool looking. Anyway, the plane is running side to side. But now we have a problem. These vectors are no longer accurate. The C, the positive and negative C, are fine, but this is no longer positive B. It's now positive A. So double click, positive A, apply, double click, negative B, change to negative A, negative A, apply. Perfect. Okay, so now we're back to where we need to be. So we change the view, update the annotations, like we just did. Arrow's still going through the center, but we changed the text box annotations. So now we're going to do the exact same thing. We're going to go to File, Export, Graphics, keep the defaults, Export. We're going to save it as just a JPEG, but I don't want to save it as the same file name. I should have changed the first one, but we'll change this now. So I'm just going to call this B-axis. Put a little tag on the end there so that I know which one is which. Replace the image. Don't want to crop. I want to replace uploading from my computer. B-axis. Excellent. Resize. And you can always change the size of your text for these vectors if it's just too difficult to see on here, if it's not reasonable. Okay. Next question. Does the B-axis intersect the lattice plane? Oh, sorry. That was also part of this first question, and I read over it. Don't do that. So, no, I don't see the surface for this first one. We didn't see the surface. We saw the edge. Does the A axis intersect? Well, going off of the description, if you can only see the edge, it is parallel. And if you can see the surface, it is not parallel and therefore will intersect. So it's not, we're not seeing the face, so it will not intersect. So no, no, the A axis does not intersect the lattice plane. Okay, we're going to ask ourselves the same question. Let's remind ourselves where the lattice plane is. We can see it here. And remember, B is now running in and out of the screen. So does B intersect this? No, it doesn't. If you watched the videos from Canvas, where somebody explaining the Miller Indices, he was talking about if there's no intersection, if it's parallel, you can think also about this intercepting at infinity, if that's more helpful to you. And that might be more helpful because remember, with the Miller Indices, you're dividing quantities. And so if you divide by infinity, that's essentially saying 0. You're dividing by an infinitely large number, which means you would have an infinitely small fraction, which is essentially 0. So if that helps, I hope that's not confusing. The point is B does not intersect this plane. So no, the B axis does not intersect the plane. It is parallel to the lattice plane. Again, don't copy me word for word there. That's just my quick thoughts. Okay, last thing, no surprise, we're going to look down the C axis and ask ourselves the same questions. And one more question at the end. Ooh, fun. Looking down the C axis. Okay, now we can see the face of our lattice plane for the first time here. So I'm going to rotate this. Now it's a little laggy. So there's the plane. And again, we've been seeing it edge on this whole time like this. It's a little imperfect, but you get what I mean. We've been looking at the edge the whole time. So let's reset to C. Now we're seeing the flat face of it. So it's like a notebook like this now instead of a notebook like this. Okay. But once again, our axial vectors are incorrect. So we're going to use our arrow tool. The A is okay. A is running horizontally, I can see. B is running up and down, though. B, apply. I'll fix that in a moment because it's all messed up. B, apply. I don't want my positive sign hanging out above my B. What does that mean? It's a little finicky, but there we go. Okay, so now we have axes correctly labeled. Perfect, we love that. So we updated the annotations, and we're going to replace this image in just the same fashion we had been. File, export graphics, export, rename, underscore C axis, save. Back to the document, replace, upload, C axis, yay, resize. Cool. So now we have to ask ourselves the question, does the C axis intersect this plane? Well, Cam told us before very helpfully up here that if you can see the surface of the plane, it is not parallel to the axis and therefore will intersect it. So imagine you're traveling down the C axis. You see just a flat wall in front of you. So if you kept going and you went through that plane and you ended up on the other side of the crystal, you can see the back side of the crystal now, you would intersect the plane. So yes, if we're talking about the C axis does intersect the lattice plane. Okay, let's get back to the question. Does the C axis intersect the lattice plane? This is set to red text. Let's change that to black text. Yes. The C axis does intersect the lattice plane. When viewing the crystal structure along the C axis, the face of the lattice plane is visible. Cool. Okay, so based on all this information gathered, what is the Miller index of this plane? And you already know the answer. You set the Miller index at the beginning of this. But let's play the game. Let's pretend we didn't know that. Let's say we were just given this crystal structure as an unknown. It has a lattice plane. We know nothing. We're very confused. Okay, so when we're looking down the A axis, we say, no, we don't see the surface of the plane. This is not necessary. I'm just going to change my text so you can see my answer. So I don't see the surface when I'm looking down the A axis. And so, like I was saying with the B axis, you can think of that as if you divided 1 over infinity, that's 0. So if I'm trying to make the, write the Miller index for this lattice plane, then I would start with a parentheses, and I would type a 0 because for A, it is 0. It goes A, B, C, or HKL. Okay, so A is 0. If we're looking down B, we also do not see, we do not intersect the plane. We're seeing the edge of the plane. There's no intersection there. Think of dividing 1 by infinity, which is 0. So our next point would be 0. C, we do intersect the lattice plane. So that'll be a 1. So the Miller index of this lattice plane is 001. And again, you already knew this. At the beginning, let's hide our lattice plane. At the beginning of this exercise, we told you to go in here, draw a lattice plane on HKL001. Well, look, it doesn't intersect A, 0. Doesn't intersect B, 0. Does intersect C, 1. Lattice plane 001, Miller Index 001. So again, hopefully that helps you conceptualize this a little bit better. 001 would intersect the C, would not intersect A or B. So hopefully getting to kind of play around with that helps set that in your mind. And if that didn't quite do it, then you'll get more practice, because next you're going to repeat the process with a lattice plane drawn on 110, and then you will also do this again with a lattice plane drawn on 111. So you'll be doing a lot of replacing images. Remember to use File, Export Graphics, as opposed to just the nice Edit Copy Graphics feature, because for some reason Copy Graphics doesn't grab the text boxes. If somebody figures out a way to do that, please comment in the video below. That would be awesome. Anyway, that should be all for this part. Hopefully we didn't miss anything. And if anyone's confused, feel free to reach out through the class site or in the comments. Thank you all, and I'll see you in the next video.